Hello, this is Ms. DB. In this video, we are going to look at how to solve a few of the problems from the Equations and Inequalities worksheet. So we are going to define variables, write equations or inequalities to match the problems, and check if a number is a solution to an inequality or an equation. So this is just an introduction. We'll work with equations and inequalities a lot more this year, but we're just going to practice writing them and solving just a little bit. So in this first example, it says, this is from your textbook, suppose there is a concession stand selling burgers and french fries. Each burger costs $2.50 and each order of french fries costs $1.75. Your family is planning to only purchase burgers. How many can be purchased with $25? So the first step is to define your variable. That just means pick a variable that you want to use for this problem. For example, you could use B to stand for burgers. You could also use X to stand for burgers or something else. So you just have to pick it and say what it is and what it stands for. That's defining your variable. Now we're going to do step 2, which is to write an equation to represent the situation. Every burger costs $2.50. It says it right here. So if every burger is $2.50, then we can write an equation that is $2.50 times B will be equal to the total that we're going to spend, which is $25. And then step 3, we have to think about how many burgers could we have at $2.50 each that would equal 25. You can solve this equation using inverse operations, where you would divide both sides by $2.50, if you remember how to do that. But you could also do this problem in your head, because $2.50, 2.5 times 10 equals 25 exactly. So we could get 10 burgers from this concession stand. Pretty good deal. They're probably pretty small. All right, so you're going to do that for these problems. You are going to define the variable, which just means pick a letter and tell me what it is, and then write the equation. And for one of these, 1, 2, 3, or 4, come back and solve the equation after you write it. Let's look at number 3. Renting a car costs $55 per day plus 45 cents per mile. The cost of the rental is $100. So for a variable, we would need maybe 2 variables. We would need one for day, how many days you have it, and we would need another one for how many miles. So let's use D for how many days, and let's use M for how many miles. Now you could use A and B or X and Y or any other letters you want, as long as you say what those are going to stand for. And then the equation. So it's $55 per day. That means $55 times every day that you have the car, and we have a variable, D, that means every day that you're going to have the car. You can write 55D like I did, or you can put a times sign in between it. Don't use an X for times, because then we'll think it's another variable. Plus, it says, so $55 per day plus 0.45, that's 45 cents, per mile. Per, again, means to multiply, and I'm going to multiply it by M. The cost of the rental is 100. If there's an is, you put an equal, or an equal sign, and then you put what it's equal to. Now this one I don't think I can solve unless I know how many days I have it for. So if you want to solve a problem, this one would be tricky to solve unless you have more information. You would need, like, maybe we need to add some information, and you can do that. You can add the information that you would need to solve it. Let's say that car is rented for 1 day. How many miles did you drive? So in addition to picking one to solve, you might have to add more information so that you're able to actually solve the problem. Like in number 1, what other information would we need? We would need, how many jobs did he do? Oh, it's 1 job. So in this one, the only variable would be per square yard, because it says Peter earns $25 for a job. So if you are going to use the variable of job, J for job, it's going to be 1 if you try to solve this one. Let's write this one out a little bit. The variable would be J for job, and should we say Y for yard, for square yard? So the equation is he charges $10 per job, so that's per, so that's times, and 20 cents per square yard. So that end is a plus. He's going to charge $10 a job plus more money for every square yard. So that would be 0.20 times Y. And it says that he earns $25 for a job. That means that the job is equal to 1. So if we were going to solve this equation, we would replace J with 1. So I'll erase that. So it's 10 times 1. I can't get my parentheses. Plus 0.20 times Y, that's what we don't know, is equal to 25. So we would be solving this question. What we would be trying to find is how many square yards was it? All right, moving on, we are going to look at some inequalities as well. An inequality is when you use a greater than or less than sign, or one of these other signs that go along with it. So there can be greater than or equal to, less than or equal to, less than, or you could even have not equal to at all. We are going to translate a sentence into an inequality. Avocados cost $1.59 per pound. How many pounds of avocados can be purchased for less than $7? Pick a variable, define a variable, means just go ahead and let it be anything. And then these are $1.59 per pound, so they're using A, so $1.59 and they put it in parentheses, but you could just write it next to each other, is less than 7 because they want it to be less than $7. And then you just go ahead and do that for these problems. And then for one of them, solve the inequality. Number 6 I want to look at because it says 2 consecutive integers. A consecutive integer is like the numbers 2 and 3. Those are consecutive integers because they're both integers and they're in a row. If the sum of 2 integers is less than 54, we have to pick a variable to be our integers. We're going to let x be one integer. We only need one variable for this problem because the other integer then, the one right next to it, would be x plus 1. Because if you did 7 and 8, if 7 was x, 8 would be 7 plus 1, x plus 1. So we have to write the sum of 2 consecutive integers is less than 54. The sum of means to add. So we're going to add x plus the integer right after it is x plus 1. And it has to be less than 54. If this was the one that I was going to solve, I would start by adding x and x together. X and x is 2x. Oops. Plus 1 is less than 54. Let's go ahead and finish this. I'm going to subtract 1 from both sides to undo that plus 1. So I get that 2x is less than 53. Now we have to divide 53 by 2. We'll get a decimal. 53 divided by 2 is 26.5. 26.5 is not an integer. 26.5 has a decimal part, so it's not an integer. So that can't be an answer. But what would it be less than? We could have 26. 26 is less than 26.5. So one answer for our integer could be 26. Maybe the other one is 27. If we add 26 and 27 together, the sum is less than 54. Because look, here's our calculator again. 26 plus 27 is equal to 53. And it had to be less than 54, so this works. But our answer really is that x is less than 26.5, and really it could be less than or greater than 26. Here's another hamburger question. That one's a different price. 49 cents per hamburger. We went back to the past. All right, then the next part here, we are going to check if we have a solution. So to check that a number is a solution to an equation, what you do is you replace it every time you see that value, everywhere you see it. And then you simplify the left side, and you simplify the right side, and you find out if you get the same thing. If you do get the same thing on the left and right side, then you'd say that yes, 5 is a solution, that this works. If you substitute something in and the left side does not equal the right side, like 15 does not equal 8, then we would say that z is not a solution. So you're going to plug these in and find out if they are or are not a solution. I'm going to do number 10 with you because it's a fraction one, and that's sometimes a tricky one to do. So the fraction is 4/3, but I want you to see how it becomes a simpler problem rather quickly. So I'm going to start with the left side. It says 3/4 times x, but x is given to us as being 4/3. So 3/4 times 4/3 plus 1/2. I want to see if that is equal to 32. I bet this is supposed to be 3/2, huh? We're going to change that on the worksheet to 3/2. All right, so we are going to simplify the left side now. The left side is 3/4 times 4/3. 3/4, where's my pen? 3/4, whoa, 3/4 times 4/3 is equal to 1, because the 3's cancel and the 4's cancel. So this is all equal to 1 plus, then I have 1/2. 1 plus 1/2. And the question was, is that equal to 3/2? You might know the answer for this already. 1 plus 1/2 is 1 1/2. And another way to write 3/2 would be 1 1/2. These are going to be equal. Let's change 1 to a fraction. 2/2 is the same as 1 because it would equal 1. And 2/2 plus 1/2 is the same as 3/2. So we get 3/2 equals 3/2. So this would be a solution, and you would say yes. You do need to show your work on these, though. You can't just say yes or no. So the fraction one turned out to be really not that hard after all. Then on this part down here, you're going to do the same thing, but with inequalities. So you'll take the value of the variable, plug it into the inequality, and see if you get the same thing on, or if you get a true statement. In this case, the true statement they won't be equal to each other. It'll just be something like, is 46 less than or equal to 70? Well, that's true. So that is a true solution then. That would be a valid, you would say yes for that one. And then 17 through 20, you just have to find the answer for the variable. You can just use mental math. You can use inverse operations. It's up to you. And then the last section, choose 3 problems below to solve by writing an equation or inequality and then solving. So there's a whole bunch to pick from. You just need to pick 3 of these. And once you got your answer, just make sure that you check it and see if it is an actual answer. All right, thank you very much. Have a wonderful day.